Page 4 of our review packet. A pyramid with a square base. Okay, so the square base is a two-dimensional base. Now, pyramid is 3D, so the capital B you're going to see is not just a one-dimensional distance across. It's not a side. It's the area of the square. We're going to call each side x, so the area is x squared. Oh, so what's different is they give us the volume, so that has to go in place of V. So when we work formulas backwards, that's what we have to be prepared for. Putting a number in for V rather than putting it on the right side. Okay, and then we're going to solve for x. So everybody handles this differently, but I multiplied the 1/3 and the 146.5. You don't have to do it that way. It's just the way that I chose to do it. So that's 48.83 repeating, I think. Okay, so then once we divide both sides by 48.83, you get 53,084. Now that's x squared. The inverse operation to squaring is square root. So you're seeing me take the square root of both sides and get 230.4. So next one, we have another pyramid. It's going to be 1/3 base times height, but it has a square base. So it's not just 6. That's a very popular mistake. It's going to be 6 times 6. So that capital B that we're going to be working with, that's going to be 36, not 6. Probably the most popular question or mistake is putting 6 right there instead of a 36. Remember, it's the area of the base when you look at that capital B in a volume formula. The capital B is a 2D base, not just a distance across. Now, of course, if you look at our choices, after we solve the problem, if you look at the choices they give us, I'm sure one of them is a choice that would have 6 here. Let's see, that'd be 20. Maybe not. That's good. So they did not trick us too badly there. The altitude is the same as saying the height. So that's that. Okay, so for number 7, they're giving us a diameter and for a basketball and a tennis ball. Got it. Okay, one's significantly bigger than the other. And they want to know how many times greater the volume of the basketball is compared to the tennis ball. Okay. Now, there's a quick way to do this and a longer way. I'm assuming we haven't taught you yet how to perform the shorter way. So we haven't covered similarity yet, so I don't expect anybody would know how to do that. I will show the quick way. It is to the diameters have a ratio of 9.5 to 2.5 or 3.8 to 1. Now, the ratio of the diameters or the ratio of the radii is 3.8 to 1. If we cube that, that's going to be the same as the ratio of the volumes. So that's the fast way. After we learn similarity, that's how we will do it. For now, we don't know that trick yet, so I'm going to have to calculate the volume of both spheres and then divide, and you'll see it's the same answer. So I'm going to go ahead and notice that carefully. You have to, they give us the diameter, so you got to cut that in half to get the radius in both cases. Now we've got to cube the radius, so please be careful of that. It's very common to square it because we're so used to squaring whenever there's an exponent. So please make sure you cube in your calculator. And then, in fact, it is the same answer. So that's it for page 4.